All right. All right. Hello. We are the relationship experts, and today we're going to be presenting about comparing quantities. We are from Math-330, section 12 to 2 p.m. So the goal of our presentation is to show the progression of number sense starting from kindergarten all the way through high school, beginning with comparing numbers, and then to fractions and decimals, to irrational numbers and proportional relationships, all the way to algebra and comparing and constructing functions. So this is our progression, first through third grade, number quantities, fourth through fifth grade, fractions and decimals, into middle school, comparing rational and irrational numbers and graphing proportional relationships, and then into high school, where students make comparisons in algebra.
All right, so we're going to start off on this first slide with kindergarten and first grade Common Core math standards. So the first standard that sort of deals with comparisons in kindergarten is for students to identify whether the number of objects in one group is greater than, less than, or equal to the number of objects in another group. And in kindergarten, it's sort of just getting the basics of comparison down. There's not a lot of mathematical vocabulary or symbols involved. There's also not a lot of number systems involved. It's sort of just using visual representations and things that students are familiar with and having them get the idea of comparisons. And then they sort of transition into comparing numbers between 1 and 10 in like written numerals. And then in first grade, they take that knowledge that they learned in kindergarten and then apply it to two-digit numbers. And then they also include the mathematical symbols of greater than, less than, or equal to. And then in second grade, they take all of that learning and understanding and then apply it to three-digit numbers and also include the mathematical symbols. And then in third grade, they take those comparisons of number systems and then apply it to a different one. In third grade, that's when they are introduced to comparing the fractions. So in this slide, we have a few sample activities. And so the one on the left side starts with kindergarten students. And so as I mentioned before, there's sort of like visual representations and a lack of numbers. So this is just for students to get the idea of making comparisons down. And so for example, on the first line, there is 4 cupcakes on the left-hand side and 6 cupcakes on the right-hand side. And so students should be able to identify which group has more or less. And then once they have mastered that, they move on to a sample worksheet in the middle, which would be the end of kindergarten or the beginning of first grade, where they take those visual representations and then apply it to number systems, usually between 1 through 10. And then once they have mastered sort of comparisons between those, then they move into an activity like the one on the right-hand side. And so those sort of steer away from visual representations and move towards three-digit numbers. And then they also include the implementation of the symbols of greater than, less than, or equal to. And it's really important for students to have a solid foundation in comparing numbers because once they reach higher grades like third, fourth, and fifth, then they are comparing fractions and decimals. But in kindergarten, they have the basic understanding of how to compare things and when one thing is greater than, less than, or equal to. And then with that foundational knowledge, then they can apply it to different systems of quantities.
All right, for fourth and fifth grade standards, fourth grade moves from what they built on in third grade with fractions, and now they're going to be finding equivalent fractions. So recognizing that AB is equivalent to n times A over n times B. And then in fifth grade, they'll be using the place values that they learned in previous grades to apply that to decimals, and we'll be able to compare bigger or smaller decimals using less than, greater than, or equal to symbols that they learned in previous grades. And for an activity for comparing decimals, we have the fruit splat game, where students can choose what sort of level they feel confident in, and then they will choose either relaxed or timed, fast or slow fruit. So the fruit have the inequality symbols on them, and then students click on the one that they think is right, and then they'll earn points. And it's just a really great activity for practicing comparing decimals. And then for fractions, we have more of a modeling activity. So students will be able to see what different fractions look like. So in this activity, they have sliders to move numerator and denominator, and then it gives a good visual model as well as the fraction, mixed number, decimal, and percentage. So that's kind of what they will be learning in the next grades. And then they will be moving on to middle school, and they'll be using, oops, too far. They'll be using what they've learned, especially with decimals, to apply to comparing rational and irrational numbers. They build on these ideas and apply it to new number systems.
Yazmin, you're muted.
Moving on to 8th grade, we will be talking about rational and irrational numbers, comparing the size of both, and and also we'll be going over key concepts such as what how can you define an irrational and irrational number, and what does that look like as a decimal and fraction, etc. Well, obviously, what can be a fraction, what cannot be a fraction, more. And then the next one will be proportional relationships. We'll be talking about how that can be represented on a line, and as a line on a graph, and as a linear, and how it can represent a linear equation. And we'll be interpreting that in terms of unit rate as a slope of the graph, and comparing different how these relationships can be represented in different ways. And yeah, stumbled a bit, but there you go. Our first activity, we'll be talking about real number card sort. We'll be doing a real number card sort, and we'll be comparing irrational and rational numbers. So with the real number card sort, students will be expected to cut out those little pieces of paper and sort them in their designated category. This is a good warm-up activity to see hey, do students actually really understand what a rational number and what a rational number is? And then our next one, we'll be actually using real, we kind of, what we've done in the previous grades, we'll be using greater than, less than, or equal to symbols and comparing two values against each other. And yeah, so real fast. And our next activity, we'll be doing Dino Crunch. Really exciting. Dino Crunch is all about having this big dinosaur, and you have to feed this dinosaur. What do you have to feed this dinosaur? Irrational numbers. So this is testing your knowledge. So yeah. Oh, good job. That was an irrational number. I don't know why, but it has this weird animal thing that's riding on the back of the dinosaur. I just think that's kind of weird, but there you go. And then fun activity for kids. So moving on, we'll be talking about proportional relationships. And so you'll be looking at this, students will be looking at this worksheet and will be observing the example. This is a really cool example because first off, it defines what a proportional relationship is. And And then number 2, it shows what it looks like on a table and a graph, and it also shows an example equation related to both the table and the graph. So awesome. And so in this exercise below, students are going to be filling out that table, seeing how it can be represented as a proportion, and relating that to how it can be used as in an equation. And hopefully, I'm assuming that we'll probably add a section in there. Hey, can you do a graph for this? That would be really easy to do. So yeah, that's what we're doing. And so now it was really awesome working with you folks, but now we're going to transition to algebra. So comparing rational and irrational numbers along with the knowledge of comparing numbers, decimals, and fractions is important because it's a foundation for comparisons in algebra, because these apply and extend knowledge to functions, graphs, and other representations. So remember that bit we talked about linear stuff. So we're moving on from that bit.
All right, in algebra, a few sample. My dog is crying. Oh my God. In algebra, one of the standards that we have is students should be able to construct and compare linear, quadratic, and exponential models. And with that, we have an activity on the next slide. And so students will have this worksheet on the left-hand side that identifies the function table and the graph. And then on the right-hand side, they'll have to cut those out and match which function is equivalent to which table and which table is equivalent to which graph. And so they should be able to understand the equivalency between these different representations, even though the information is the same. And then on the slide before that, so these are just a few examples of models. And so since linear, quadratic, and exponential functions are just all different rates of change, students should be able to identify and compare which rate of change is greater or smaller, or if they're equivalent. So that is an activity that we have for algebra. And that sort of builds on everything that they learned from kinder up until middle school, where they started out comparing numbers and then moved on to the other number systems like fractions, rationals, irrationals. And then they still use that idea of comparison, just applying it to fractions, or not fractions, functions and different rates of change.
All right, so to recap, we went over in the beginning grades of elementary, comparing number quantities using symbols all the way up to 3-digit numbers. Then we had 4th and 5th grade, where students compare fractions and decimals. On to 6th through 8th grade, where we had irrational numbers, as well as different proportional relationships. And then we moved on to high school, where we made comparisons in algebra to different kinds of functions and being able to recognize what these functions look like and compare them to each other. So yeah, thank you for watching and listening to our presentation.